Hello students, welcome to the session. In today's session, we will be discussing about pair of straight lines. So this is one of the most important chapter in paper B and let us get into the concepts. See where to start with this pair of lines. Pair of lines before getting into this one, ax square plus 2hxy plus by square is equal to 0 is a homogeneous second degree equation. What is this? Homogeneous second degree equation where A, B, H not real numbers, not all zero. For example, if A0, H0, B0, nothing will be there. So any one can be zero or any two can be zero, but not all the three are together zero. And degree is second degree. This is second degree. Throughout the equation, we have the second degree. So we call it as homogeneous. And you know how to check the homogeneous equation? If replace x with kx, y with ky, then if it is ending up with k to the power of n into f of x comma f of y, this is called nth degree homogeneous equation. So this is the second degree homogeneous equation. And this is a second degree general equation. This is called general second degree equation. It's not homogeneous because this is second degree, here second degree, here second degree. But these two are linear, it's 0 degree polynomial. Okay. And there is a maximum, there is a lot of ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This is a general second degree equation. See, it can represent pair of lines. It can represent a circle. It can represent a parabola. It can represent ellipse. It can represent hyperbola. So, under different conditions, it can be. So, now we are going to study this pair of lines. So, what exactly the pair of lines? Pair. In the name itself, they are talking about pair. Means two lines. The product of two lines. L1 is this and L2 is this. The product of this one is pair of lines. So actually here there are the two types actually. What happened? A1x plus B1y is a line passing through origin. A2x plus B2y is another equation passing through the origin, which is combined equation may gives us ax square plus 2hxy plus by square. So it can be real, it may be imaginary. It's depending on the discriminant, depending on h square minus ab. And if this equation like not passing through the origin, a1x plus b1y plus c1 into a2x plus b2y plus c2 is equal to 0. This combined equation we will be writing as, sorry, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c. So these are the two lines passing through the origin. Their combined equation gives us a homogeneous second degree equation. These are the lines not passing through the origin. You are going to get this equation. Here what happened? Ax square plus 2hxy plus by square is equal to 0 represent pair of lines passing through the origin h square greater than or equal to ab. Why h square is greater than or equal to ab? So now I can write by square plus 2hxy plus ax square is equal to 0. So I will be writing this is b times of y by x whole square plus 2h times of y by x plus a is equal to 0. It is representing pair of lines through the origin. So I'll assume y is equal to mx is one of the line. So y by x is equal to m. So this is bm square plus 2hm plus a is equal to 0. It's a quadratic equation. When this equation will have two real roots, delta should be greater than 0. Two distinct roots. Delta is equal to 0, two identical roots. Delta less than 0, no real root. So from here only you are getting 4h square minus 4ab. So h square greater than ab, you have two real lines, h square equal to ab, two coincident lines, h square less than ab, two imaginary lines. Okay. So for example, you have the equation like 2x square plus 5xy plus 3y square. How you can write this one? Simply you can write it as 2x plus 3y into x plus y. Just look at here, 2x square plus 3xy plus 2xy, 5xy plus 3y square. So this can be reduced into two different lines. Okay. So ax square plus 2hxy plus by square is equal to 0 represent two real lines. H square should be greater than or equal to AB. Next, if ax square plus 2hxy plus by square is equal to 0 represent pair of lines, sum of the slopes is minus 2h by b and product of the slopes is a by b. So what you write is ax square plus 2hxy plus by square is equal to 0. So I will be writing this one as y minus m1x into y minus m2x. This is one way of writing, or this also can be written as L1x plus m1y into L2x plus m2y. We can represent this way, this way. So this is more preferred way. But here y square coefficient is 1. Here y square coefficient p. So I will write p. So on comparison of this and comparison of this, you will be getting m1 plus m2 is equal to minus 2h by b and m1 m2 is equal to a by b. And if you are taking this part as the consideration, you will be getting L1 L2 is equal to a, M1 M2 is equal to b and L1 M2 plus L2 M1 is equal to 2h. So sum of the slopes is equal minus 2h by b and product of the slopes is equal to a by b. This equation, this pair can be represented as either y is equal to m1x and y is equal to m2x or L1x plus m1y and L2x plus m2y also. Absolutely no issues. So what is the angle between the pair of lines represented by this one? See, not only this one, even if the pair is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c. Because these two are pair of parallel lines. These two are pair of parallel lines. So what is the angle between them? Cos theta is equal to plus or minus means modulus, acute angle if you are taking modulus of a plus b by under root of a minus b whole square plus 4h square. So how we are going to deal? So I'll be taking as ax square plus 2hxy plus by square is equal to L1x plus m1y into L2x plus m2y. So now these are the two lines. What is the angle between them? Cos theta is equal to modulus of L1 L2 plus m1 m2 by square root of L1 square plus M1 square into L2 square plus M2 square. So this is comparison L1 L2 x square. What you are going to get? L1 L2 x square plus L1 M2 plus L2 M1 into xy plus M1 M2 y square. So from here you are going to get modulus of a plus b by square root of, because L1 L2 is equal to a, M1 M2 is equal to. This is L1 square L2 square plus M1 square plus M2 square plus actually you will be getting L1 square M2 square plus M1 square L2 square. That I'll write L1 M2 plus L2 M1 whole square minus 2 L1 L2 M1 M2. So from here you are going to get modulus of a plus b by square root of a minus b whole square plus 4h square. This is also can be done tan theta is equal to also. Tan theta is equal to also. That value 2 root over h square minus ab by a plus b. 2 root over h square minus ab by a plus b. Why? Here tan theta, further simplification, you can do that one. And clearly if a plus b is equal to 0, okay, if a plus b is equal to 0, those lines are mutually perpendicular. Okay, right. So what is the node point? If theta is acute angle between them, the lines, then this is what is this? Actually, this is cos theta is equal to, and this is tan theta is equal to, there is a printing error. Okay, cos theta is equal to a plus b by root or a minus b whole square plus 4 whole square, and tan theta is equal to 2 root over h square minus ab by a plus b. And if a plus b is equal to 0, those lines are parallel. Yes, here. Theta is equal to 0, then the lines will be coincide and tan theta is equal to 0. If h square minus ab is equal to 0, h square is equal to ab. If theta is equal to pi by 2, then two lines are perpendicular. Cos theta is equal to 0. A plus b is equal to 0. Means we are talking about coefficient of x square plus coefficient of y square is equal to 0. Yes. Equation of pair of lines passing through x naught, y naught and parallel to this. What is the value? Okay. See, if I am writing ax square plus 2hxy plus by square is equal to, okay, like L1x plus M1y into L2x plus M2y, right? I need to find the pair of parallel lines, to this one passing through x naught, y naught. So any line parallel to this one passing through x naught, y one, and any line parallel to this one passing through x naught, y naught. So what is going to happen? That is L1 times of x minus x naught plus M1 times of y minus y naught is equal to 0. Similarly, the second line is going to be L2 times of x minus x naught plus M2 times of y minus y naught is equal to 0. What is the product of these two lines? That is L1 L2 into x minus x naught whole square plus L1 M2 plus L2 M1 into, okay, x minus x naught into y minus y naught plus M1 M2 into y minus y naught whole square is equal to 0. So from here clearly L1 L2 is equal to A, M1 M2 is equal to B, and L1 M2 plus L2 M1 is equal to 2H. Just substitute, you are going to get this equation. And also, any line perpendicular to this one, pair of perpendicular lines to this one is going to be bx square minus 2hxy plus ay square is equal to 0. This is pair of perpendicular lines. Why? Perpendicular to this equation will be m1x minus l1y is equal to 0, and the perpendicular to second line m2x minus l2y is equal to 0. So when you multiply this one, m1 m2 x square minus of l1 m2 plus l2 m1 into xy plus L1 L2 y square is equal to 0. So it will be reduced to this particular equation. And any line perpendicular to this one and passing through x naught y naught, here you will get b x minus x naught minus 2h, remaining thing same, plus a times of y minus y naught whole square is equal to 0. And let me also explain you one point here. Okay, what is that point is ax square plus 2hxy plus by square plus 2gx is equal to 0. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This always forms a parallelogram. This is always represents a parallelogram. If this is 0 comma 0, this is a 1 and 2. Combined equation of 1 and 2 is this. And this is the combined equation of 3 and 4. You know the point of intersection of this, point of intersection of this. In the rotation of the axis, changes of axis we have already done. So what is that point? The point of intersection is this. That is HF minus BG by AB minus H square. Okay. GH minus AF by AB minus H square. Okay. And this is the point, this is the point. And you need to know what is this diagonal. At this point, this equation satisfies, and at this point, this equation also. So from here, you can take one of the diagonal as 2gx plus 2fy plus c is equal to 0. Now, this is always a parallelogram. When it can be a square or rectangle. When it will be a rectangle. It will be a rectangle if a plus b is equal to 0. Why? If a plus b is equal to 0, this angle 90, this angle 90. So in this one, rectangle means it can be a square also. And the next one is, for example, this is, you know, this slope is minus g by a minus g by f, and you can find the slope of this one. If this is angle is 90 degrees, then it will be a rhombus. So we need to check it out whether given parallelogram is a square or a rectangle or a rhombus with the help of a plus b and slope of this line and slope of this line. Next question is angular bisector. So what is meant by angular bisector? If this is one line and this is another line, L1 is equal to 0, L2 is equal to 0. Locus of points which are equidistant from this, locus of P will be angular bisector. This and this. These two are mutually perpendicular. So those equations are this one. Okay. For example, C1, C2 greater than 0. C1, C2 greater than 0. That plus sign will give us the angular bisector, which is bisecting the angle of the region containing the origin. Okay? Right. But here more important, this is one is the when you take plus sign and one take minus sign. Once it is acute angle bisector, another one is the obtuse angle bisector. The pair of angular bisectors for the equation ax square plus 2hxy plus by square is equal to 0 is this. So what is that? The first line is I will take L1x plus M1y is equal to 0. Another line I will take it as L2x plus M2y is equal to 0, where L1 L2 is equal to A, M1 M2 is equal to B, and L1 M2 plus L2 M1 is equal to 2H. So if the point is there, locus will be there. So what you are going to get, L1x plus M1y by root over L1 square plus M1 square is equal to plus or minus L2x plus M2y by root over L2 square plus M2 square. When you simplify, you are going to get this equation. What is that? H into x square minus y square is equal to a minus b into xy. So that this is one angular bisector and this is another. So this angle is equal to this and this angle will be equal to this angle. And always angular bisectors, pair of angular bisectors are always mutually perpendicular. Product of the perpendiculars from alpha comma beta to pair of lines. So this to pair lines, here alpha comma beta is the perpendicular distance P1. This line is L1x plus M1y is equal to 0. This is L2x plus M2y is equal to 0. This is P2. So what is P1? P1 is equal to L1 alpha plus M1 beta by root over L1 square plus M1 square. P2 is equal to with modulus because perpendicular distance has to be positive. L2 alpha plus M2 beta by root over L2 square plus M2 square. So from here, P1, P2 is equal to this value. You are going to get this. Okay. Products of the perpendiculars from alpha comma beta to given line, given pair of lines. Area of the triangle formed by ax square plus 2hxy plus by square is equal to 0 and lx plus my plus n is equal to 0. So what I will do is, these are the pair of lines 0 comma 0. Instead of taking this one as L1x plus M1y, I will take y is equal to M1x and I'll take here y is equal to M2x. So when I'm taking this one, the product is equal to this. So here you'll get M1, M2 is equal to A by B and M1 plus M2 is equal to minus 2H by B. And this is the line Lx plus My plus N is equal to 0. Y is equal M1x you substitute here. So what happened? Lx plus M1yx plus N is equal to 0. So x is equal to minus N by L plus M1. So this point is minus N by L plus M M1 and y is equal to M1x. So minus N M1 by L plus M M1. Similarly, y is equal to M2x you substitute minus N by L plus M M2 and here minus N M2 by L plus M M2. Now one vertex is 0 comma 0, one vertex is x1 y1 x2 y2. Area of the triangle is half modulus of x1 y2 minus x2 y1. So half modulus of is simply you look at this into this minus this into this. So n square times of m1 minus m2 by product will be L plus M M1 into L plus M M2. If you simplify this, you are going to get area will be equal to n square into root over h square minus ab by. Actually, I have m plus m1 plus m2. Here m1 minus m2 is there. So from here, m1 minus m2 whole square is equal to, I can write it as m1 plus m2 whole square minus 4 m1 m2. I need to tell you one more point. Okay, right. Now a line lx plus my plus n is equal 0 is given. I need to find this line is here. Somewhere origin is here. I want to find pair of line such that it will form an equilateral triangle. So the combined equation of that pair 1 and 2 combined equation is Lx plus My whole square minus 3 times of Mx minus Ly whole square is equal to 0. This is the pair of equation forms an equilateral triangle with Lx plus My plus N is equal to 0. Okay, clear? Next, one more point, homogenization. Okay, like this is a curve. Equation is like ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. A line is intersecting this. This line is like Lx plus My is equal to N. I need to find the combined equation of OA and OB. What is the combined equation of OA, OB? Combined equation for this. So you need to homogenize this equation with this line. So what I'll do is, I will take this line as Lx plus My by N is equal to 1. I will take this one as 1. Now this equation is, I will write it as Ax square second degree 2hxy second degree plus by square second degree plus 2gx. It is a first degree. So I will write into 1 plus 2fy. This is first degree into 1 plus c 0 degree. So 1 square is equal to 0. In the next step, I will write this value in place of 1. So you are going to get ax square plus 2hxy plus by square plus 2gx into, okay, so just what I'll do is I'll club and write these two. 2gx1 plus 2fy, because it is a linear equation, will be multiplied with lx plus my by n plus c into, you will write lx plus my by n whole square is equal to 0. This is called homogenization. And this equation will be written into form of, it reduces to ax square plus 2hxy plus by square is equal to 0. Okay, this is called homogenization. So, with this one, I am concluding the session. Thank you very much. We'll continue solving the questions in the coming session.